All right, welcome to Unit 11. That's going to be our final unit this year in pre-calculus. Normally we get through Unit 12, but given everything that's occurred, this is going to be it. So day one, we're going to talk about properties of exponents, and a lot of this is going to be review of things that you've covered in the past. So our objectives, we're going to review and use the properties of exponents, and we're going to evaluate and simplify expressions using them. When you see these properties, I'm going to show you the basic boring book definition, and I always put a numerical example in because I think that works better. So we'll start here with the product property. If you multiply two numbers of the same base, you add your exponents. So here you see we have both of these are base x, so 5 plus 7, x to the 12th. If you have a product to a power, very similar, you take each number inside a parentheses and raise it to that power. So here 4x cubed, we're going to cube the 4 and the x. Simplify when you can, so 4 cubed we know is 64. Here, getting a little bit ahead of ourselves, but 2 to the third, that's 8. And when you raise a power to a power, we'll actually see this one on the next slide as one of our properties. You multiply, so x to the 15th. Last one here, you see the same base again, so we add exponents, so 3x to the 7th. 3 to the 7th is 2187, and x to the 7th. So this is kind of a combination of these two properties, which is why it's on this page. All right, here's that power to a power. Again, if you raise an exponent to an exponent, go ahead and multiply them. So x to the 40th, 6 to the 27th. When you get a number like this, go ahead and leave it because it's going to be gigantic. And we don't need big long decimals and scientific notation, no need for that. This is our quotient property because we're dividing. When you take the quotient, go ahead and subtract your exponents as long as they're the same base. So x to the 13th minus x to the 8th, so 13 minus 8 is x to the 5th. And 11 minus 8 will be 12 to the 3rd. And once you start getting to some bigger numbers, as long as the exponent's not too big, you can go ahead and do that. So 12 to the 3rd is 1728. If this was the 7th or 8th power, we'd probably just leave it because, again, you get a ginormous number. All right, negative exponents. You cannot have a negative exponent in your final answer. And so really the property of that is you take the reciprocal. You go 1 over this number. And key point here, a can't be 0 because we can't divide by 0. So x to the negative 7th is really 1 over x to the 7th. 2 to the negative 2nd is 1 over 2 squared. 2 squared we can simplify, so 1/4. If you have a negative in the denominator, then you go ahead and move it up to the numerator. So this really becomes 3 to the 4th, or 81. Again, our previous property here is our product property. Still works with these negatives. So 7 plus negative 5 is x squared. Quotient property as well. We still subtract. So 7 minus negative 5 is x to the 12th. And our last one here, 5 minus 7 is negative 2. Again, I can't have a negative in my final answer. So 1 over x squared. All right, go ahead and move me out of the way. There we go. If you take a fraction to a power, then you just raise each number to that power. Again, the bottom number can't be 0 because we can't divide by nothing. It's undefined. So 2 to the 5th, 32. X to the 5th stays as a variable. If you have a negative, that's okay. If you see a negative exponent, go ahead and take the reciprocal of this right away. So I change this to y over 3 and make it positive 4. So y to the 4th over 3 to the 4th, which is 81. Anytime you have the negative first power, that's just a reciprocal. So 8 over x becomes x over 8. 4/3 and the negative first becomes 3/4. All right, rational exponents. That just means fraction. So you see here we got a to the 1 over n. It's the same as a root. So x to the 1/2, that's the same as the square root. X to the 1/3 is the cube root. 1/4 is the 4th root, so on. The bottom number, the denominator, is the index of your root. And the top number becomes the power of the number that is inside the radical. So for example, when you look over here, x to the 3/4, it's the fourth root of x cubed. Typically, I'll write it this way, although this is okay as well. You can put in the root in parentheses and put the cube on the outside. Here we have the 16th root of x to the 7th, 8th root of 2 to the 5th. Again, it works both ways here. So if you see 64 to the 1/2, that really means the square root. You don't have to rewrite it as a square root, but that's what you're doing. Square root of 64 is 8. Cube root of 64 is 4. All right, 0 power. Any number to the 0 power equals 1. That is always true. The only caveat here, the base can't be 0. So because 0 to any power is just 0. So a variable to 0 power is 1. A positive number, whether it's an integer, whether it's a fraction, decimal, doesn't matter. Positive number, 0 power is 1. Same holds true for negatives. Holds true for fractions, whether it's a fraction with or without variables. So you can see this entire expression, it's to 0 power, so it's 1. This is a larger algebraic expression. Again, the entire thing is in parentheses. So since the entire quantity is to 0 power, it also equals 1. And again, fractions, whether it was 19/7 or whether we have an algebraic expression like this one with the x and y, if the entire expression is to 0 power, equals 1. Where you have to be careful is right here. You see x to the 0 power, but that is the only number that's to the 0 power. So that number becomes 1. So we really have 16y to the 5th. So that's the one thing to look for. You got to ask yourself, is the entire number raised to the 0 power, or is just part of the number? If the entire quantity is raised to 0 power, equals 1. And if just one of the numbers is to 0 power, then that particular number is 1, and you have to multiply it out. All right, kind of extension of what we've done here, a few more examples. So now I have a product. We're multiplying all these numbers together to a power. So I've got to take every number here to the 6th. This is technically 2 to the 1st, even though there's not an exponent there. So 1 times 6 is 2 to the 6th. Negative 3 times 6, x to the negative 18th, and y to the 30th. 2 to the 6th is 64. This negative has to go to the bottom. So there's my final answer. Same idea here. Two ways we can do this. So I can cube everything right away. That's what you see here. So 5 to the 3rd, x to the 12th, negative 2 times 3, negative 6 times 3. Then I got to address my negatives. This one goes to the denominator. This one goes up top. So that's one way to do this. The other way is to take care of the negatives right away. So version 2, I move the y squared to the denominator and z to the negative 6th up top, and then raise everything to the 3rd power. You see we get the same answer here. It's 2 steps either way, so it's really your preference whether you want to cube everything first, then simplify, or address the negatives first and then multiply it out. Right here I have a fraction to the negative 4th power, and so what I'm going to do with that, before I even multiply all this, you want to make sure, take a look here at your bases, and since this is negative 5th minus negative 3, this really simplifies to 2x to the negative 2nd. Now I'll raise this to the negative 4th, so 2 to the negative 4th, x to the 8th. This expression right here goes to the denominator, and so we get x to the 8th over 16. You could, if you wanted to, you could have multiplied this out right away, then I would have got 2 to the negative 4th, x to the 20th, x to the 12th. Then we could subtract here, and again move that to the bottom. So we get the same answer either way, about the same amount of work. Again, that's your preference as far as what you see fit and how you want to tackle that. All right, home stretch, last slide here. If you have a fraction like this one, where we've got the variables and I've got numbers here, ignore the variables for a second. Ask yourself if you can reduce this. So 15 over 24 reduces to 5/8. Now I'll tackle the variables. So negative 6 minus a negative 2 is x to the negative fourth. That goes down to the denominator. So again, if you can reduce your numerical fraction, do that first, then tackle the variables. All right, last one right here. So I take 2 times 3, negative x to the 6th power, and negative 4x to the 10th. Now, be careful here. I have students mess this up all the time. The negative here only applies to the 4. This is a positive exponent. So really, this is negative 1 over negative 4, or 1/4. 6 minus 10 is x to the negative 4, so that stays down here. So really, kind of think of this as it's x times x times x, or 6 of them up top and 10 of them on the bottom. So 6 of them cancel out. You still got 4 on the bottom. So negative divided by negative is a positive. 6 minus 10 is negative 4. If you had negative 4, you move it to the bottom, make it positive. All right, that's your properties of exponents. That should help you with worksheet number 1 from Unit 11. Thanks a lot.